Hey guys, welcome to today's video where we're going to be looking at the J1850 project. So that GM Class 2 module that I did, it uses the MC68HC58 IC that Motorola and then Freescale sold. So yeah, we're going to take a look at this project again. We have Rev C of the board out now. I know I've had this board for like a month and hadn't done a video. I've been really busy just trying to get some other projects up and running and get some stuff going for this project. So let's take a look at the board and see what differences we have here versus Rev B. And then we'll actually get into some software on it so that way you guys have a better idea of how to use it. And just like before, I'm still selling these on my eBay. So if you want to buy one from me that's already built, it's there. Or on my GitHub, you can download the stuff and just build one yourself. So totally up to you on how you get going on this project. I am using a Arduino Pro Micro clone, so it's like a Leonardo but with less pins. Okay, well yeah, let's take a look at this. All right, so here's a nice close-up of the Rev B versus Rev C board. So as you can see, they're pretty much the same component-wise. I just fixed some stuff on the silk screen mostly. So yeah, you'll see that Rev B of the board was missing the labels here, while Rev C has it. And then I actually have some different components on some of the Rev C boards. So when I first started the Rev C boards, I was using the same diode. However, I ran out of these ones and they were out of stock, so I substituted to a different diode. So you can see a different diode here. They also obsoleted the PWM chip that I was using here on Rev B, and so I have substituted that as well on Rev C. It is a pin-for-pin substitution. Same with the diode, they're pretty much the exact same spec. The other thing I did is I moved the jumper to the top of the board. Again, this jumper is for enabling this output here on the 12-volt pin. It's really 14 volts, just like a car would be, but I just labeled it 12 volts. So yeah, the jumper here is so that way you can either bring 12 volts up to power this and, you know, not populate the boost converter if whatever application you're having, you already have 12 volts available. Or if you're doing something like this where you're using an Arduino, you have this boost converter here that takes the 5 volts, makes it into 14 volts. Yeah, this data link chip requires anywhere from like 9 to 16 volts on one of its pins for the transceiver portion of this data link IC. So yeah, that's what the jumper's for. You can either bring in or take out power. This board has the jumper as well, but it's on the back of it. But I figured if you had it soldered in, it's kind of a pain to have to desolder it to get there. There's also a test point on the back here that is there for, again, testing your boost converter just to see if it's not working. But yeah, as you can see, there are no components on the back side of any of the 3 revisions I've done of this board. I kept all the components on the front so that way it can sit nice and flush on your project if you're going to just use this as a module for communication. You can also see that I substituted out C6 and C5 to a larger package. It's actually just because I have an entire reel of these, so I figured instead of buying the same cap, just use the one that's in a larger package. Because again, I have like 4,000 of this capacitor, so I just substituted to something I had on hand. But that really covers all of the changes here. Okay, well, let's start out with looking at the GitHub here, so that way you know where to find everything, because it's in 2 different repositories. We have one for this Visual Studio program that you're about to see, and then another one for the firmware and the board views and all of that stuff. So let's go ahead and open that up. So this Pro one, the 68HC58 Pro, that is the actual program. So that one's the one for Visual Studio, where you can clone this repository directly into Visual Studio and do it. It's a Windows form in VB.net, so that's just kind of the background on that one. And then the other repository is the J1850 repository, and that has the board files, which are in these folders here, and then the firmware, which is in this folder. So, and then just kind of a README file here that shows you some information about them. So let's go ahead and take a quick look at the firmware, so that way we don't have to get into Arduino IDE too much. So on the firmware, it's pretty basic. It's a little state machine that has 4 different states, and it uses a function right here to check for command, and then it has a loop where it actually does whatever function it's in, or whichever state it's in. And then there's a little bit of a delay here. You can remove that delay, it'll work just fine. The delay is really for the standby. I should have just left it there so that way it's not sitting there constantly looking to see if there's another command. But yeah, so the 4 functions, really there's only 2 important ones, which are the TX and the RX. The RX, what it does is it stays in that state the whole time, calling 2 different functions. First, the check for command to see if it needs to change states, and then second, the actual RX data. And the RX data is a pretty simple function as well. All what you have to do is send this empty data bit and this command bit. You can get more details on how this RX function's working in the Rev B video, because I kind of explained how to do that in that video. And then the TX, it works a little bit differently, because it will just TX it takes the data, converts it from ASCII into hex, and then sends it along its merry way, and then it leaves the TX state, goes back to standby. So that's how the firmware works. And then, oh yeah, there's that last command, which is the identify, which also it does is print a string, so that way we can identify what we're talking to. That state there is really for the program I'm about to show you, so that way we can make sure we're talking to the right COM port when we're doing it. It's just kind of some error checking to make sure we're not connecting to the wrong COM port while trying to communicate to the device. And again, this firmware is really for an Arduino that's connected to the module. The module itself doesn't need any firmware. It runs on its own. I'll try to remember to add the data sheet to the IC in the GitHub here as well, so that way you don't have to go looking for the data sheet if you want to do something other than the basic programs that I've made for it. These programs are really just there to try to get you guys started on whatever project you're trying to do with this module. All right, finally, let's take a look at this program that I actually wrote for it as well. So again, you can clone this repository straight into Visual Studio, but it is a Windows form in VB.net. It has a couple of dependencies to it, which are the I/O ports and the system threading. So those 2 dependencies are needed, but your computer should automatically pull them in if you're using the Git repository to do it. If you copy and paste it, then you may need to manually do that. Yeah, it's got some of the settings hard-coded into it, because we know the firmware is always going to use these settings. And then we really only have like 156 lines of code, so it's a pretty simple program, not a lot going on in it. Most of the magic happens here in this subroutine, or in the send line subroutine, which is here. That one should be the subroutine for it. One of the things to note here on the send subroutine is it's not checking your data to make sure it's good. So you have to kind of sanitize your data yourself before sending it, because the Arduino isn't really doing much to handle it either. So that's just one of the things. And also it doesn't support scripting yet. Maybe I will add it, maybe one of you guys, because it is GitHub. You can just put a request in to push something, and I'll probably approve it. Feel free to try to make improvements on this, because I do not feel like I'm a master programmer. I have no formal training. So yeah, this is just kind of me stumbling my way through it, but let's go ahead and start it up so you can kind of get an idea of what this program does. All right, so we need to hook back up the Arduino and connect to the right COM port, which is going to be COM port 4 for me. We are connected, and then we can just put it in RX mode, and now we'll start receiving the frames as they come in. So yeah, that's how this program works for data logging. If you're going to try to data log something, you know, as you saw in the Arduino thing, it's, you know, you get that RX. I used that RX symbol at the beginning to let us know, like, we should process this data as if it's an RX. And then the status bits are still in there, so we know if we're at the start of a frame, the end of a frame, or if we have more data coming. So that's why all of that information is in there when it's sending it. It's to let this program process it into a complete frame like that. And then yeah, we can put it back into standby mode. It does the that identify command in the beginning to make sure you're actually hooked up to one of these. And if it responds, then it'll let you send these. So these buttons are grayed out if they're not. If you're not in the right mode. And then again, you can send data, but you have to send like the frame as like a full frame. So you just have like each bit. So you just make sure you have enough to make one, and then you can send it. So pretty simple to use, pretty straightforward, but again, doesn't support scripting yet, and not the best way to data log it. And I've never actually hooked this up to a car. There may be some other frames that come in that give some other status bits that I didn't account for. So definitely something that you may run into problems that need to be corrected. It's just I don't have a car that speaks J1850 to plug into to actually test this. I'm not a mechanic, so I don't do this stuff every day. So I do have to kind of just simulate it here on the bench. I'll hook up like an instrument cluster here or there, but I don't have like a full car to actually hook up and make sure that it plays nice with a car. So definitely, you know, it's a work in progress, and everything here that's released is just for you guys to try to make something that works. Well, that's about it for the Rev C video here. I really don't have too much more to say here, other than it took me a long time to make this video because I first wasted a bunch of time on little projects like this, where I was thinking maybe a 3D printed case would be useful for it, but then kind of realized, well, who would ever need just the module in a case, because you're going to need an Arduino as well. So, you know, some time was wasted on tasks like that, but yeah, also I had another project I was working on, which is this, which we'll do a video on here soon, because I'm not going to have to go into too much detail because it's a brand new project. But yeah, this is single wire CAN instead of the J1850. So this one is the GM LAN single wire CAN. It uses the exact same footprint. We do have 2 more pins coming down for the mode 1 and 0 of that transceiver IC. But yeah, it is a single wire CAN module in the same footprint. You may be noticing a trend here with this footprint that I may be kind of making a standard for something that I want to sell. So I may have an idea for something in the future. But I don't know how far I'll get with the idea. So right now I am just kind of trying to stick to something that would work with this idea. But I'm not going to say anything on it because I just don't want to promise something I can't deliver. But yeah, definitely been trying to use the exact same footprint on these modules as I move along. So that way I have something that is modular, hence the name module. But yes, have another project coming up soon. See a video on this hopefully soon. Hopefully it won't take me 2 months to do a video. If you want to buy one of these, I currently have, what, 2 or 3 of them put together for sale right now, and I have 30 more of the boards coming. So I should be able to get some more up on eBay shortly. So if you go checking my account and there's none available, then that's why. But I do have the parts coming to build at least 30 more of them. I have all the parts to do 30. I have 30 of these ICs, so I definitely plan to build and sell at least 30 of these. They do take a lot of time to assemble, and this chip is getting expensive to source in China because, you know, it is obsolete. We're working with something obsolete here, something that was probably obsoleted around 2005, 2006. And here we are in 2024 using it. But yeah, if you're already working in a project with a Rev A board, don't forget you can just swap right into this Rev C and it shouldn't give you any problems. The only major difference is that you don't need the 12 volts coming up there, because this one needed both 5 and 12. This time you don't need it. It doesn't affect anything if you do have it, because you have that jumper there. But yeah, that's really all is what's different between these two. Is that requirement for the 12 volts and the size of the board. This doesn't have the full LC filter that you're supposed to have on that thing. So, you know, the wave shaping was probably not quite as good on the Rev A modules anyways. There's not too many of those floating around though, unless anybody was downloading the files to build them themselves. Not really sure, but I know I only sold a handful of them and gifted a couple of them to some people. But yeah, you know, I don't want to forget to thank Mike again. You know, he's the one that told me that these ICs even exist. And so, you know, again, you know, Rev A never would have happened without him. And he really helped get all of this stuff up and working for the first couple of them. So still a big thank you going out to Mike for even showing me that these data link chips exist. I don't think you'll see another revision of this board anytime soon. The only reason I can think of to revise it again is to change out from the PLCC package to the SOIC package, but I haven't found a good source for those SOIC packages, so haven't bothered spinning up a board for them. The only good place I know of to find the SOIC package of this is inside of the Trailblazer instrument cluster. So if somebody wants to send me like 20 of the Trailblazer boards, I can pick the IC off of them, but elsewise I just don't see any point of spinning up a Rev D that uses that particular package. But yeah, you can actually find this IC inside a lot of the mid to late 90s GM PCMs, like the Camaro PCM should have this inside it. A lot of the Buicks and stuff, you can get them in there. So if you're looking for a source to scavenge one of these ICs instead of buying them from China, they are inside a lot of GM products. They just don't have this name on it. So kind of what you're going to want to look for it is find that data pin and trace the data pin and look for it going to one of these PLCC packages, and you'll probably find the right IC. There are more sources for this IC out there, but again, I just don't see any rush to respin and make a Rev D of the board. I think Rev C is probably my last one, unless some component goes obsolete on here that'll be hard to replace, or we just can't find any more of this IC that's already obsolete. I hope you guys like the video. I hope you like the new revision of the board. If you want to support the channel, feel free to buy one of these. They do cost me a little bit of money to make. This IC is, you know, getting expensive to source out of China, and it takes time to put this together. Plus, I mean, the boost converter with the magnetics also is not exactly cheap. So, yeah, we have some time and money invested in these boards, so they're not dirt cheap. But I think this is probably the way you're going to want to go if you're trying to do some GM conversion here, especially if you want to go with GM LAN to J1850 or other way around, J1850 to GM LAN. It looks like I probably have you the full package of what you need. But yeah, I hope you guys liked the video. I hope you want to support the channel, and I'll see you guys in the next one.